So yes, Duncan's asked me just to give a little taster of some of the teaching that I'm involved with. And so I've just chosen my very first lecture in the data analysis skills course, which is the compulsory course for everybody on the on-campus programs. Obviously, in the first 20 minutes of the first lecture of this course, it's not going to get very technical, but hopefully it will give you a flavor, a feel for what you can expect. So the topic I've chosen is where we start in data analysis skills, which is visualization. So think about data. Obviously, all of our programs are built around data, but what is that all about? So there's some data. So what the programs are designed to do are to help us find meaning in our data. So obviously that page full of numbers in and of itself doesn't directly communicate anything, but we know often that there is meaning, there are insights to be gleaned. And just in case that perspective doesn't work, sometimes we need to step back from the data and see it through a certain lens, through a certain set of methods, and that will reveal to us the meaning in our data. Now, one of the really key methods that we use to reveal the meaning in our data is visualization. Just a quick question here. If you've got your chat open, can you tell me how many 7s appear on the screen just now? Okay, so a few people have come up with a number. It took a few seconds to get some responses there, though. But what if I ask the same question, but with that data? Straight away, those 7s are not difficult to see, and within maybe 2 or 3 seconds, we can make that calculation. Similarly, if I'd made the 7s a little bit bigger, that would have helped, or even if I'd changed the angle of the 7s. So what I'm trying to demonstrate here is visualization tap into things that are inherent in our understanding. And just to give that a little bit of concreteness, these things are called pre-attentive attributes. And basically, they are visual properties that we notice without using any conscious efforts. So the things that I've just demonstrated there, things like color or size, form, or positioning, or even movement, these are things that our brains process without us being conscious of that processing. And really, that's why visualization, data visualization has such power, because it harnesses those pre-attentive attributes. It makes the most of those pre-attentive attributes. And so, as well as thinking about the type of data that we deal with and the way we want to describe it, we also need to think about these attributes. So I just want to give a couple of examples before we get into some detail. This is an example I just saw 2 or 3 days ago. I think it was published in The Economist. And I suspect it's something most of us can relate to, regardless of our gender. It's basically looking at Zoom fatigue. Now, I think within maybe 10 or 15 seconds, looking at those plots, we have a sense of what this article is going to go on to describe in more detail. It firstly highlights the differences that have been seen between men and women in this study. And basically the article is built around the difference being that women, on the whole, they tended to have higher Zoom exhaustion and fatigue scores, as shown by this plot here. So the light blue shape labeled women is sitting to the right of the darker blue shaped labeled men. If we want to drill down into some of the details of that, then there's even more detailed comparisons given on the right. But just an example straight away of data visualization being used to highlight some insights or some meaning that these researchers have found in their data in quite an effective way. Have a look at that plot. What do you think, just spending a few seconds looking at that plot, have a think about what the takeaway message is meant to be? I would argue that maybe the takeaway message that most of us get immediately looking at this plot is that the blue line has in general higher values than the orange line. And then when you look at what the line represents, it's representing daily COVID cases. So blue is more daily COVID cases than orange, And then you look at this legend and you see that the orange is mask wearing, but the blue is non-mask wearing. That, I think, is the impression that most people would get looking at that plot for the first time. But when you look a bit more closely at the plot, what you see, or what you infer, is actually that the plot is based on two different axes superimposed on the same plot. On the left, you've got the axes which gives you the masked levels of COVID infections. On the right, you've got the unmasked levels of COVID infections. But what we straight away see is that these scales are not comparable. Actually, this one sits entirely above this one. So if we were to put both of these lines on the same scale, the blue would sit very much below the orange at every stage, at every date in this plot. So I'm sharing this as an illustration of very bad data visualization. So whilst data visualization has a lot of potential to be really useful in communicating meaning and insights, it can also be misused and actually at least confuse or perhaps even mislead the audience. So for good and for ill, data visualization has a lot of power. So that's why we as data analysts and as statisticians need to be thinking about this. Remembering just back a minute there to those four different pre-attentive attributes: color, form, spatial positioning, and movement. I'm going to ask you for your view on what could potentially make that plot better. You can choose more than one. So just take a few seconds, look at that plot, try and get a sense of what it's trying to communicate, and then think, how could that be improved? Which of those on the left, the first four are the pre-attentive attributes, the last three are just some other ideas. So have a look at what you think might be going on. Thank you very much, everyone who's given me some responses so far. I'm seeing, it seems there's a high consensus on option E there. Actually, a different plot is better in this instance. So I would totally agree. So let's just go on and have a look at how we might improve that visualization. So this on the left is an example of a pie chart, which are very common. You'll see them used extensively in the literature, in the media. But actually, in terms of the comparisons that these are designed to make, the bar chart on the right is actually a far more efficient use. So what it's done is it's actually removed a lot of the color. So color doesn't necessarily help. It can actually get confusing if there's too much of it. So it's actually removed that. But then it's ordered and it's listed the different categories with very clear links to their different values. And the values are represented clearly by the length of the chart. So straight away, you get a much clearer sense of the comparisons across these different groups. Similarly, I would say the same thing for these donut charts. Again, the data on the left is given in three different forms, different donuts showing the proportion of that circle which corresponds to the percentage in the data. But again, compare that to the bar chart on the right, which has the same categories, but much more clearly the comparisons can be made across the different groups. Have a look at this one. How would you improve on that plot? Okay, it's a bar chart, so we've seen a few good examples of bar charts being used. But how do you think you could improve on that plot? Great, some good responses coming in just now. So there's a unanimous view on one of the options. No one's actually chosen the option that stands out to me just yet. Oh, one person just has. 80% of us are agreeing that actually this plot could do with less information. And again, it's like color. Sometimes we think more the better. Information is the same. Sometimes we think more the better, but that's not the case. So let's have a think about this one. Here, we've actually taken away some of the information, some of the unnecessary, the images that were used. But I think the real value here is when we shift the perspective onto the side so that the spatial positioning is different. And again, it just makes it far more clearer and far more immediate as we read the labels, as we see the pictorial representation of the data, and then we see the X values. And then the last example I wanted to give was just this one, which again shows 4 different categories, but clearly the advantage here is if we could order those categories. I think there is a debate here whether this is actually the best version we could come up with. I think this has been ordered essentially on decreasing percentages, but I think looking at the categories, you could also very clearly make an argument for swapping the bottom 2 so that you've got this progression from excellent to average to mediocre to awful. So again, it's just highlighting the decisions that we take when we think about data visualization. Okay, I've just tried to use some examples there to just get us thinking about data visualization. But when we get into the technicalities, and this is what this course will go on to teach us, it's no trivial matter to construct these sorts of plots. And obviously the plots that we've looked at so far have been quite straightforward, but the more complex the data, the more complex the visualization potentially can be. So what we'll do in data analysis skills is we're going to really delve deeply into what's called the grammar of graphics. And it's a framework that was come up by Leyland Wilkinson. Basically, the grammar of graphics introduces us to the idea of these layers so that we can introduce layer upon layer to our visualizations, and those layers combine to give us effective visualizations. So it's almost a philosophical way of thinking about visualization. The way we will implement that in practice is using what's called the ggplot2 package, which is a package within R, the software, and it's part of what's called the tidyverse. And we'll use a lot of tidyverse packages in data analysis skills because it's a comprehensive way of thinking about our data, not just thinking about visualization using ggplot2, but thinking about processing or wrangling our data, or modeling our data, or using inference with our data. So a lot of the methodology that you'll have seen in other courses, we will go on to really implement, but we'll implement it through this framework called the tidyverse. And the reason we're going to focus in on the grammar of graphics, and in particular ggplot2 as a way of producing these plots, is because these are becoming increasingly common in the media, across the scientific literature. And here's just an example. The BBC uses R and especially ggplot to produce a lot of its graphics. Clearly, they have teams of data journalists working on this, so they can invest a lot of money to get to get the precise qualities that they want. But just to understand that sitting beneath each of these plots is our code. So the very code that we'll be using to produce our visualizations can be used to produce the highest quality of visualizations. Right, what I want to do in just the last few minutes is to get us going with ggplot2. And what I would like us all to do is, if we could just scroll down just below figure 14. So just below figure 14, you will see this, what's called a console. And basically what this is just some R code, which if you click run, it essentially processes that R code. And you can see from just looking at this plot, it's ggplot, the function, and that is one of the functions that has come out of ggplot. So that's it, produce it for me just there. So it's just produced that plot. But what I want to do is I want to just demonstrate how would we begin to build up on that plot. So obviously the first thing we could do is we could change the color. Okay, let's just do something fairly trivial. So what I'm going to do is add that color. So I'll stick that code in the chat so you can just copy it in. So I've included an extra parentheses there. So when I delete that parentheses, so you're just inserting that. And then when I run that code, I should get exactly the same plot. Yes. And it's bright blue. Okay. So we can start to have control over that. But actually, the most important thing I want to do is I want to replace these codes on the x-axis. I want to replace them with more meaningful labels. So I'm just going to, I'll add that to the chat. So you can take that. If you just add that in to the same line, then what it's done is it's taken not just the abbreviations, but it's taken the whole name as the label. Now, straight away, it's done what I've asked it to do, but you can see it's not very clear because obviously there's a lot of overlap now. But remember what we saw in that last example, or the second last example, was often if we can just invert the axes, that creates a much clearer demonstration. So what I want to do is invert the axes by just adding this coord flip. So if you want to copy that over and add that to the line as well, all it does is it flips those coordinates, the X to the Y, and it gives us a much more meaningful layout. Straight away, I can see the different airlines, I can see the number of flights, and etc. So that's just a very quick example to illustrate how to build up the code in ggplot, but also to demonstrate, introduce you to these interactive tutorials. And on the left, you can see all the different sections that we'll consider in this one lab, all the different types of plots. So this is something we use extensively in data analysis skills, just to get us all going so we can play around and experiment with the code without needing to spend lots of time getting things set up. So that was the code that I was going to step us through. I've just highlighted some of those bits. Now, just to reassure everybody, obviously that code that we just looked at, it wasn't entirely obvious or intuitive, but just to reassure us that there's a lot of resources available. So here's an example. There are these cheat sheets that go alongside these tidyverse packages, which I really encourage my students to familiarize themselves with. Nobody is asking anybody to memorize lots of different functions and lots of different arguments and the different orders, but we need to know where to look to get them. So these cheat sheets prove to be exceptionally useful. I would say within a couple of hours of just doing some work with the ggplot tutorial, you'll be able to negotiate and then navigate your way around these key functions as summarized on that cheat sheet. And then the last thing I wanted to do is wanted to finish with this plot, another plot. This is a different type of plot. This again appeared in the Economist not too long ago. And it's basically trying to communicate that the start of the cherry blossom season in Japan, if you look at that plot over time, it's showing that certainly in the last sort of 100 years, there seems to be a trend going down. Now, the reason I wanted to highlight that plot was that trend line that's been superimposed, that's drawing on an extensive range of statistical methodology. And other courses in the program will talk us through that and give us a good understanding of where that modeling comes from and how that modeling works. So I wanted to illustrate that. Visualization can often be a great way to present the results of our very sophisticated analysis. But the other thing I liked about this plot, just coming back to some of the subtler things, was this little correction that the Economist published on April the 7th. They say in an earlier version of this chart, they depicted the cherry blossoms with 6 petals rather than 5. This has been amended and they've asked for forgiveness there. So what I liked about that is they've obviously chosen these little images, these little petal images, but they were corrected when they used an image with 6 petals rather than 5. So there are layers upon layers of attention that we can spend on these data visualizations. Just to finish with, data visualization is often the best place to start because it gives you, the analyst, insight straight away into what's happening in the data, and that needs to be emphasized. But also data visualization is extremely useful at the end of the analysis and when we want to communicate the results to people. So I would argue that our data analysis or our analytics, it both starts and it ends with data visualization. And that's why it's such a key part of the toolkit of any statistician or any data analyst.